Hey everyone, welcome to my channel. I have started a personal DSA challenge where I am solving 5 problems per pattern, covering 180 problems in total. I'll be posting one video per day explaining my thought process from brute force to optimized approach. If you're new here, you can check out the previous videos to follow along. In today's video, we'll be working on running sum of 1D array. So the problem states that we are given an integer array nums and we need to find the running sum. Running sum is nothing but the sum of all the elements till that index. So we need to return the running sum array. So the idea for brute force approach would be for each index I, we calculate the sum of all the elements from index 0 till the index I. This means for index 0, the sum is nothing but the first element. For index 1, the sum is nothing but the sum of 1 and 2, which is 3. For index 2, it is nothing but the sum of all the indices from 0 till index 2, which is 6, and likewise. So let's code it up for the brute force approach. Let's take a variable n as nums.length, and also we need one array, resultant array of size n, and let's loop through from 0 till the n, and let's take one variable sum to reset it for every iteration. We need to initialize it here before starting up the another for loop, and j also starts from 0 but j runs till I index because we are running from index 0 till the index I for every iteration. So j plus plus, and let's add it up to the sum nums of j, and at the end we will return the result. Let's run the code. Oh yeah, and also we need to update the resultant array after every for loop, which I missed. Let's do that. Would be equals to sum before the sum is reset to 0. Let's update it in the resultant array and then we will return the result. Now let's run the code. So here it is working, but we are recomputing the sums again and again from for every index. For example, if you take this index, it is just the input number. For index 1, we are summing up from 0 index and 1 index to get 3. And for this index, we are summing up 1, 2, 3 to get 6, which is unnecessary. So we need to think of an optimized approach. And so the key observation here is that we are recomputing the sum every time at every index, but that is nothing but the already calculated sum plus the current element. Let's initialize the array int of, okay, it's not length, and the first element is nothing but the current element, the first element at index 0 of the input array. So let's assign it, and index 0 is already taken care, so we need to start from index 1, I less than nums.length I plus plus, and here the sum, the result of every index is nothing but the previous sum plus the current element. So result of I minus 1 plus nums of I, and we will return the result. Let's run the code. It is working. Let's submit it. Okay, it is accepted. So one more optimization which we can do is, instead of creating a new result array, we can modify the given input array and we can um, make the changes there. For that, first let me dry run this so that it will be easy for you to understand, then we can do this in place. So for example, the result initially would be empty, and result of 0 would be nums of 0, which is nothing but 1, which is nothing but 1. And from the second loop we are simply taking the previous sum from the resultant array, which is 1, and the current element, which is current element at index 1, because the indexing starts from 1. So we are simply adding up this and the previous sum. So 2 plus 1 would be 3, and then 3 plus this 3 would be 6, and 6 plus 4 would be 10. So that's how we got the running sum. So now if you want to do this in place instead of creating a new resultant array, what we can do, we can simply loop from I1, I less than nums dot length and I plus plus, and we are updating the input array. Nums of I plus equals to nums of previous element, which is nums of I minus 1. Let's we will return this nums and let's submit, run it. It is accepted, and if you submit it, it will be submitted. So by doing this, we are saving this extra space of O of n. So this is called in-place optimization. So the edge cases here are, in the single element array, the answer is the same element, which is obviously taken care, but in negative numbers still works because addition is consistent. So yeah, this problem is a classic example for introducing prefix sum. And yeah, that is it for today's problem, and I'll see you in the next one.